Let's look at taking the inverse transform of 7s minus 1 over s plus 1, s plus 2, s minus 3. In order to do this, we're going to have to deal with partial fractions. And we notice the denominator is all linear, and we have none repeated. So the way we do this is we're going to take our original fraction, 7s minus 1 over s plus 1, s plus 2, s minus 3. And on the right-hand side, we're going to set up a fraction for every term on the denominator, or every factor on the denominator. So an s plus 1 fraction, an s plus 2 fraction, and an s minus 3 fraction. The tops will become our coefficients a, b, c. And so anytime we have the denominator being completely factored into linear terms with none repeated, this is how we need to set it up. From here, I'm going to multiply everything by my original denominator. S plus 1, s plus 2, s minus 3. So this becomes a 7s minus 1 since the denominator in this term here will cancel. With the first term on the right-hand side, the s minus 1's cancel. I'm left with an s plus 2 and an s minus 3. The second term, the s plus 2's cancel. I'm left with s plus 1, s minus 3. And then the third term, the s minus 3's cancel. I'm left with s plus 1, s plus 2. We now need to solve this, and we can do this by selecting nice values for s. So I'm going to start by letting s be equal to negative 1. This side would have 7 times negative 1, which is negative 7, minus 1. Negative 1 plus 2 is 1. Negative 1 minus 3 is negative 4. Here I would have a b times 0, and here I would have a c times 0. So this is the only thing I'm left with. Negative 8 equal to minus 4a, or a is equal to 2. Next, I'm going to let s be equal to negative 2. The left-hand side would have 7 times negative 2, or negative 14, minus 1. If s is negative 2, this term here is 0, so there will not be an a term. For b, negative 2 plus 1 is negative 1. Negative 2 minus 3 is negative 5. And then the c, this term here will go to 0, so this whole thing goes to 0. We then have negative 15 equal to 5b, or b is equal to negative 3. Finally, I'm going to let s be equal to 3. On the left-hand side, 7 times 3 is 21, minus 1. On the right-hand side, this will go to 0, and this will go to 0, so I don't have an a or a b. 3 plus 1 is 4, and 3 plus 2 is 5. So we end up with 20 is equal to 20c. So c is equal to 1. So now I'm going to rewrite this. This was of the form a over s plus 1 plus b over s plus 2 plus c over s minus 3. And now I'm going to use the fact that the transform of e to the at is 1 over s minus a. So that would make this term here, this first one, 2 times e to the minus t, since a would be negative 1, minus 3e to the minus 2t, since a would be negative 2, plus e to the 3t, since here e would be equal to 3. So this is my inverse Laplace transform.